Hi guys, welcome to my channel One Data Byte. Before jumping into the Python introduction, let me start by explaining what is a computer. A computer is an electronic device that executes the instructions to perform operations. So what is a computer program then? A computer program is a set of step-by-step instructions that a computer has to follow to reach goals or complete tasks or execute computations. Now, what is a programming language? Simply, a programming language is a computer language in which instructions are written in a computer program to perform operations. In human language, we use words and grammar to construct sentences. Whether it is English, Bengali, or Hindi, we have to construct sentences using the words and grammar of that language. Where words provide the structure of a sentence in a specific language, while grammar arranges those words to provide proper meaning to the sentence. Similarly, in programming languages, we need syntax and semantics to construct a computer program. Syntax is similar to the collection of words in a specific language, and semantics is similar to grammar. Each programming language has its own set of syntax and semantics for properly constructing a program. Syntax provides the structure of a program in a specific programming language, while semantics give the structure its proper meaning. For example, the sentence "you what is name" does not make any sense, right? This means that simply arranging words is not enough. We also need to apply proper grammar to make the sentence meaningful. The correct sentence is "what is your name?" Similarly, to create an effective computer program, we have to arrange the syntax according to the proper semantics of that programming language. Now that we know what is a computer program, and a programming language, let me quickly introduce Python. Python is one of the most popular general purpose, open source, cross platform, interpreter based modern programming languages, or we can say scripting language. For now, just remember these terms: scripting language, interpreter, cross platform, open source, and general purpose. I'll explain each one by one, so don't worry if they seem new to you right now. Before that, let me explain the history of Python in few words. Python was created by Guido van Rossum. Python is a successor to the ABC programming language, which was developed in the early 1980s. Although ABC had some good ideas, it was not widely adopted. Guido took the inspiration from ABC and developed Python in the late 1980s to make computer programming simpler and more enjoyable. If we look at the timeline, we'll notice the evolution of the wheel above the Python versions. Why have I added this? The reason is to think of each wheel as a newer version of Python. The first wheel works, but as time passes, engineers improve its design to make it stronger, faster, safer, and more efficient again and again. Similarly, every new Python version introduces improvements, fixes bugs, enhances performance, adds new features, and removes old limitations. In 1991, Python 0.9.0 was released. It was the first public version and introduced many of the Python's core features. In 2000, Python 2.0 was released, and this is when Python started becoming popular among developers. In 2008, Python 3.0 was released. It was a major redesign of the language. Some old features were removed or changed to make the Python clearer and better for the future. Because of these changes, Python 2 and Python 3 existed side by side for several years. However, the last version of Python 2, 2.7.18 was released in 2020, after which Python 2 reached its end of life. This means it no longer receives bug fixes and security updates, so it should not be used for new projects. Although old projects should also be upgraded according to the newer version of Python. Currently, Python 3.0 continues to evolve every year. Just as newer wheels become more advanced, new Python versions become more secure, more efficient, and include new features. According to the Python Software Foundation's support policy, each annual Python 3.0 release receives about 5 years of support, including bug fixes and security updates. After that, the version reaches end of life, and users are encouraged to upgrade to newer supported version. That's why whenever we start learning or building a new project, we should always choose a current release stable Python version instead of an outdated one. At the time of creating this video, Python 3.14.6 is the latest stable version, and Python 3.15 is on the way. It is available in beta version. If you want, you can use, but I will prefer to use to a stable version. If a newer stable version has been released by the time this video is being watched by you, then please use the latest stable version instead of Python 3.14.6. To know more about Python's versions and history, jump into the Wikipedia page given below. It will give you more understanding about the Python's history. Now let's start with the terms that we noted during the Python introduction. First term, what is a scripting language? Right now, we already know what a programming language is. Similarly, a scripting language is mainly interpreter-based, simpler and shorter version of programming language. Second term, what is an interpreter? Before understanding the interpreter, let me describe how a computer system works behind the scene when we pass instructions to complete some computations through any computer program written in a modern programming language. Most modern programming languages like Python use syntax written in English so that humans can easily read and write the instructions. So basically, by using modern programming languages, we are passing instructions to computer in English, right? But does a computer directly understand English and simply follow our instructions? The answer is no. A computer can only understand binary code, which is a combination of zeros and ones. Therefore, to convert our human readable program into binary code that a computer can understand, we need an execution method. This method translates our instructions into machine language so that the computer can execute them. There are two execution methods for this type of conversion. First one is compilation. For this, we need a compiler. And second one is interpretation. For this, we need an interpreter. So what is a compiler? A compiler is a program itself that reads the code and translates the entire code into machine level instructions, that means binary code, to create an executable file which can be executed further directly. And what is an interpreter? An interpreter is a program itself that reads the code and translates the code line by line into machine level instructions, again binary code, to execute the computations. This diagram explains the differences between the compiler and the interpreter, as we already discussed in their definitions. So here you can see the compiler converting the source code to executable file by reading the source code totally, and we can execute the executable file again and again for our computations. But in case of interpretation, interpreter does not read the source code totally. It will read the source code line by line and execute line by line for the computations. Different programming or scripting languages often have one or more specific compiler or interpreter implementations. Like you can see, for these programming languages, I have added few implementations of interpreters for each programming languages, and same I have added for the scripting languages as well. As I said previously, scripting language is also a programming language, so don't be confused between these two terms. These are not differences. I'm just dividing the programming language, which are basically compiler based computer languages, and scripting languages, which are basically interpreter based computer languages. So let me explain the different implementations of Python interpreters. Actually, main implementation of Python is written in C, which is also known as C Python. This means that the main Python interpreter is written in C, correct, which is responsible for executing most of the Python programs. Even Databricks uses this implementation. However, there are also other implementations of Python, such as Jython, written in Java, IronPython, written in C Sharp, PyPy, a restricted subset of Python, and many others are also in market. Now, returning back to the third term, what is a cross-platform programming language? A cross-platform programming language means a language that can run on multiple operating systems or devices with little or no modifications. Fourth term, what is an open source programming language? An open source programming language means a language source code is publicly available, allowing anyone to view, use, modify, and distribute it under its license. Fifth and final term, what is a general purpose programming language? A general purpose programming language means a language that can be used for a wide variety of tasks rather than being limited to a specific function or use case. Okay, let me recap the things about Python that we have explored so far to make a decision on why to choose Python as a programming language. Python is a scripting language, that's why it's simple to read and short to write, which makes it easy to learn and understand. Python is open source, that means it's free and that's why it has a larger and active community of users and developers. Python supports a huge set of internal and external libraries, which empowers users to tackle a wide range of computing tasks easily. Python is a general purpose programming language. That means users can use it in different computation fields like data science, web development, and many more. Python is a cross-platform language. That means user can use it on different operating systems such as Linux, Windows, and macOS. Python is dynamically typed and garbage collected, so we don't have to worry about the garbage collection in Python. It supports multiple programming parallelisms, including structured, which is practically procedural language capabilities, object-oriented and functional programming capabilities are also supported in Python. Python is most popular programming language among data professionals due to the high demand of Python in data. Python is the most popular language among the data professions, as I said, such as data engineers, data scientists, and data analysts. Python is used in almost all of the major data applications like scientific computing, data analysis, artificial intelligence, machine learning workloads, and many more. Almost all of the leading data tools across the globe are supported by Python, like Spark, Delta, Airflow, and so on. Python is supported by almost all of the most popular data libraries, such as NumPy, Pandas, Matplotlib, Scikit-learn, OpenCV, TensorFlow, and etc. etc. Okay, the course path will follow this flow. In this course, we'll go from basic to advanced Python programming capabilities. And in terms of course goals, our main goal in this course should be making the computer work for us by writing programs. To achieve our course goal, we must know about automation. Automation is the process of replacing a manual step with one that happens automatically. Knowing when and where to use automation is very important. Let's take this example. Suppose we have 3 files in our file system and we need to organize them into folders based on their creation dates. With such a small number of files, we can easily do manually. Writing an automation script for these tasks would not be worthwhile for this situation, right? But imagine what happens if there are thousands of files with new ones begin added every day, and we need to organize them over the course of a year. I hope you can understand the complexity of managing such a large and continuous growing collection of files manually. This is where automation becomes essential. We need to write a computer program that can automatically organize the files into corresponding folders for us based on their creation dates and saving time and reducing manual efforts. Okay, let me quickly explain the objective of this course. You might be wondering why we should take this course instead of many others available online. The reason is simple. I don't just teach theory and practical coding. In every topic, I will introduce real life scenarios to help you identify actual problems, understand how to approach them, and then solve them using computer programs. This practical problem solving approach will help you to think through a programmer rather than just memorizing concepts. By the end of this course, you will not only understand Python, but also know how to apply it to solve real world challenges with confidence. Since this Python from beginner to expert course is a sub-course of the data engineering with Databricks program, we'll be using the Databricks platform to begin our Python journey. This will not only help you to learn Python quickly, but also familiarize you with an industry-grade platform that is widely used by data professionals in various big data projects. Okay, we're done with the Python introduction. In the next video, I'll explain what Python is as a programming language by introducing elements of the Python syntax and write our first Python program in the code editor to display Hi Python. Thanks for watching this tutorial. Stay tuned. I'll see you in the next video.